guys, for the warm welcome. It's always good to be back. I don't know if this got covered in the intro, but Peter and I used to co-chair this committee many years back together, 2012 through 2015, I believe. And so it's always good to come back and see what you guys are doing, check in, and kind of share some of the stuff that I've been working on in my practice. So as you probably gathered from the synopsis, and if you're here for something else, maybe we can entice you to stay, but we're here to talk about, the title of the presentation is Towards Carbon Positive Architecture. And the idea here is that we're going to show lessons learned from a decade plus now in net zero energy buildings. And so my name is Blake Jackson. I'm an architect here in Boston. And I work for Stantec, which is a global company. And we do everything from small interior fit outs all the way up to, we just completed the extension of the Panama Canal and everything in between. Primarily my practice here is on urban planning, some workplace, but the majority of it is multifamily with some mixed use commercial buildings. And my role within the company is as the Northeast US Sustainability Design Leader. And so I'm supporting Article 37, LEED certifications, well buildings, fit well buildings, passive house, you name it, across the Northeast. So Boston, as far south as DC, as far west as Chicago, and as far east as London, and sort of everything in between. So it's why I look older in person now than this photograph, because that that will naturally age a person a lot. But anyhow, with that comes a lot of credentials, and hopefully, I'd like to share this with people that I've never met before, just to say that, look, this is sort of part and parcel for the type of work that we're doing, and hopefully this gives you trust in me that I'm telling you information that is going to be useful to you later. So again, thank you for welcoming me. And I couldn't have put this presentation together without my team. And that's one of the benefits of being at such a large company, is you get to leverage a lot of really smart people and what they're doing in order to pull this together. So just a shout out to say that this isn't the work that's just done by one individual. It's done by hundreds of individuals over the course of many years. And so Rachel Bannon Godfrey, my sustainability design leader in Denver, Horace Antia, who's energy modeled, I think, all 40 of our net zero energy projects. So his entire career has been energy modeling for this type of work. And then Dr. Andrea Frisk, who's our passive house and building science expert in British Columbia in Vancouver. So really great team that helped me pull this presentation together. And we're trying to add to it over the years just to keep it relevant. So as you'll notice, the icon at the bottom left, this was presented, it's been presented a bunch of times. I think that the Connecticut AIA conference in 2020 was the year that the presentation was quite good. So that's why I pulled from this one for you guys today. And we'll try to add in some anecdotes that make it 2021 ready, as well as 2022 forward looking. So what are we here to talk about today? We're here to talk about how the idea of net zero and carbon positive buildings is gaining momentum, what that looked like in the first 10 years, because it took about 10 years to go from proof of concept to now it's a thing that is being asked of by the cities and the permitting municipalities and et cetera. And then what it means to transition towards this post-carbon civilization that we're looking at. And we'll talk about the process and some of the innovative practices, as well as some of the DNA that hasn't really changed in terms of how do you achieve a net zero energy building. And we'll do a deep dive into two case studies that are both Stantec projects to talk about those lessons learned, and again, innovative new practices, as well as just good design DNA that hasn't really changed since the beginning of this. And so we'll start by, in terms of AIA learning objectives, we'll talk about the drivers for net zero in North America. We'll talk about both active and passive design strategies. We'll do a deep dive into the technologies, and then the tools and the processes that help firms get there. And all of this is about not only just doing it once, but sort of this idea of mainstreaming. This idea. So hopefully that's why you guys are here. And any questions before we get started? Because we've got plenty of time, and I want to make sure that in a forum like this, it tends to be a bit of a one-way discussion unless people are jumping in. So I encourage everyone to jump in ad hoc or at will. If you've got burning questions or you want to make comments or something wasn't clear, I strongly encourage people to do that. And we'll have some strategic pauses throughout the presentation to encourage people that are a little bit shyer. But I'll pause now. Any questions, any thoughts? Going once, going twice? Okay, well, let's get into the momentum. So who is enabling net zero to mainstream? And I like to start with this image because it's certainly not this group. So if not this group, who is it then? Well, it's a complicated scenario, but what I've tried to do is to build this case to say that when we first started talking about net zero energy construction, circa 2010, we were really looking at it very one-dimensionally. So it was really this sort of notion of life cycle savings relative to cost premiums above building code. And codes at that time were not nearly what they are today. And the codes today aren't nearly enough to get us to net zero and reduce and draw down all the carbon that has already been emitted into the atmosphere, right? So this got us not very far, just looking at first cost versus return on investment. If you fast forward to halfway through the last decade, we're starting to round out the discussion in a much more meaningful way. So codes and standards are starting to pick up in their stringency. They're not there in where they need to go yet, but they're starting to target this and to give the carrots and the sticks in order to move raise all the ships in that direction. Resiliency became a big driver in projects, and not only climate mitigation, but also sheltering in place and what that meant relative to net zero energy construction and durability and maintaining thermal comfort indoors for longer periods of time during disruption. Health and well-being, as we're fully aware now, is a major driver and something that came into mainstream about 2016. And what does net zero energy construction mean for health and well-being in terms of indoor air quality in particular? And we've started to talk about the social benefits of zero net energy construction in buildings relative to cost savings long-term, affordable housing, and disposable income for various different families and various different social groups, or just some of the pieces of the puzzle that were starting to come together about halfway through the decade. And now you really start to see this infusion of corporate responsibility, the UN Sustainability Development Goals, the proclivity now of renewable energy technologies, surpassing that of the utility fossil fuel-based grid system being more cost-effective option. And this thinking about long-term goals of buildings and how they can adapt to climate change mitigation between now and at least 2070 here in Boston. If you've done an Article 37 project, you'll know what I'm talking about there. And also tied into the UN Sustainability Development Goals, you start to have treaties like the Paris Accord, which are legally binding documents that are trying to get first, second, and third world countries working together to solve this problem of climate change. And where do buildings and the built environment and even the power grid play into that? So this just shows you how the conversation has really grown over the course of the last decade to really become a robust discussion where buildings become a piece of this, but it's not just about the return on investment any longer. It's about how does a built environment fit into these larger societal goals, larger corporate goals, and how can we demonstrate that buildings have a resiliency inherent to them, health and well-being inherent to them, and a social benefit. So the whole conversation about sustainability has fundamentally changed over the course of the decade, and zero net energy construction in buildings are a component of that. And so how much is being built? Well, as you can see, these numbers need to be updated, but we're above 600 now. In 2019, when this presentation was last updated, we were approximately 580. And so you can see the trajectory of this moving from early in the decade from roughly about 60 buildings to, tenfold by the end of the decade. And so you're starting to see this upward trajectory, and certainly 600 buildings isn't going to change the greenhouse gas emissions of North America, but it's a start. You can subdivide that into say that there's more than 10 in every single state, for example. And where is it being built is also encouraging to me, because it is happening somewhat everywhere, irregardless of difficulty of climate or benignness of climate, irregardless of political will, red versus blue states, for example. We're starting to see net zero energy construction finding its way into every different type of climate zone, and both politically and geologically, so to speak. And what's encouraging is we're starting to see it really growing along the Sun Belt. So you can see here in climate zones 3, in the Sun Belt, this is really starting to take off in areas that are not just Mediterranean climates of Southern California, or politically motivated climates such as the Pacific Northwest or even New England and the Mid-Atlantic states. You're starting to see it in places where you wouldn't necessarily expect. And this is just that last map expressed in a very different way. And again, you can see it is almost everywhere. And there's pockets of net zero energy development that you wouldn't necessarily expect, such as around Phoenix, Salt Lake City, Atlanta, and Minneapolis. So it's happening in various different climate zones and various different levels of difficulty to achieve, but it is happening everywhere, which is encouraging. And why is this happening? Well, even though we probably will have a political seesawing back and forth of whether or not the country as a whole is in the Paris Accord, what we saw when the United States pulled out in 2016-17 was that the cities and some of the leading states decided to stay in and have been mandating local ordinances and building codes within those states, and in stretch code, like in Boston, for example, and other parts of Massachusetts, to target those goals in incremental ways. And so just because the country pulled out didn't mean that the leadership of the governors and the state and the major cities pulled out. And by keeping those major population centers in the areas where building construction is growing and happening, this has helped to move this along in a way that perhaps if we had all fallen victim of the pulling out of the Paris Accord, we may be 4 years stunted in terms of where we are today versus where we could have been or should have been. And this is just a look at what one of those case studies is. And since this is Boston and this is where the majority of my practice is, I wanted to just highlight how Boston is targeting a post-fossil fuel future by 2050. And this graph may be moved up at some point. So we're calling it 2050. At some point, we have to stop kicking the can down the future, because in 2010, we were talking about 2030. Suddenly, that's just around the corner. So now we're talking about 2050. We've somehow got to lasso it in a little bit and bring it a bit closer to time and to create incremental steps. And so the carbon-free Boston 2050 master plan is a way at which we can transition utilities, buildings, waste systems, and transportation systems from fossil fuels to a renewable-based system over that course of time, or moving from 17% renewables today to 90% by 2050, acknowledging that there will be some place for natural gas and fossil fuels, but not the bulk. And also looking at zero waste and zero transportation emissions. And this is all going to be predicated by ultra energy efficient buildings. So one of the challenges here is that we want to electrify our buildings, but it's not cost effective to do that unless they're hyper efficient. And this is why you're starting to see passive house starting to be requested and to take off in popularity, because that anticipates the capability of buildings being able to run off a future fully electric or mostly electric utility grid. And also the potentiality for maximizing on-site renewables as well as on-site battery storage systems is something that is starting to gain traction. And we're starting to have to anticipate how buildings may adapt to those technologies over time. But this is sort of one example, and every one of those dots is doing it a little differently. For example, another another version of this in the city of New York, which has local law 86, which is essentially their Article 37. A component of that has been leveraged to somewhat eliminate the ubiquitous all glass and steel towers in New York, which has caused a bit of a political stir, but perhaps it could spawn some innovation as well. So everyone's doing this a little bit differently. And, I like to show this image because this is sort of what the future of cities is going to look like. And it's made up of these various different components, which are both commonplace, such as smart homes, LEED Platinum buildings, smart buildings, offsite wind and solar, as well as new infrastructure that gets layered on, such as multi-energy stations, intelligent transportation systems, battery storage, electric bus fleets and distribution system, and perhaps even electric autonomous vehicles, for example. And so I like this image because the city of the future doesn't look drastically different from the one that we have now. And the idea is that we would be working with the systems that are in place to improve, enhance, and make them better. And this is part of kind of this idea about the Green New Deal, that it's not just about the new buildings coming on, but an overhaul of the infrastructure, as well as a deep energy retrofit of the existing buildings, which got us to the greenhouse gas emissions levels that we're at today. So it's not just about the new construction being as efficient as possible, but about drawing down carbon that's already been emitted and being emitted today. So codes, rebates, and subsidies. So this is just a look at the falling price of solar on the left-hand side, starting in 2007, and it's continued to trend down. It's still trending down today, as well as states which have adopted emerging net zero energy, or at least very low energy building codes. And Boston is one of those. And there are discussions right now about how to leverage Berto version 2.0 in order to achieve this goal. And I imagine that we'll be doing what Toronto did and other parts of Canada have done the last decade, which was to implement carbon taxes and requirements for greenhouse carbon neutral operations in various different facility types, including healthcare, which is a big challenge, and it's a big opportunity for us here in Boston, given our environment. But we're starting to see codes moving in this direction in various different locations across the country, and typically where the population centers are and where the economic development is happening. And it's not just falling costs for solar, but also renewables across the way, as well as other technologies, which at the beginning of this last decade, we're still not necessarily all the way across the board in terms of buildings. So we've seen a drastic fall in LED bulbs. We've at least seen battery cost falling, but not necessarily becoming cost competitive yet. But that's why we're anticipating that in the future. And we've started to see wind energy, solar power, and distributed PV be all falling to a point where now it makes economic sense for projects to both employ them on site as well as invest in them offsite. And this is just a look at community solar and one of those offsite investments. This is a field in North Carolina, and it may not seem like it relates to us here in Boston, but actually this is the farm that is creating the carbon neutral pact between the Post Office Square development, MIT, and BMC. So this is their offsite power purchase agreement investment, and this is the solar that is making that happen. So what I'm trying to explain here is that there's an opportunity for buildings which have room to play, that have sites that can facilitate on-site wind and or solar. Or if you're an urban site with a well-established historic footprint with a high energy use intensity, such as research facilities or health facilities, or office buildings with zero lot lines in the city of Boston, you can offset this issue to areas and invest in solar where it's cost effective to produce, because the national utility grid is connected in the way that it is. And so this is one way of finding cost-effective means by which institutions who can't do it on their own parcels can do it throughout the system. And so this idea of systems thinking about net zero and carbon reduction is very much a tool that's now being leveraged by large institutions locally. And here, the climate is much better for producing solar. The land is much cheaper, and is producing green jobs in red states, so to speak. And just at the beginning of pulling this presentation together, when there were the trade wars going back and forth, east and west, there was a thought that the tariffs put upon Chinese goods, such as solar panel products, was going to reverse the trend of their downward trajectory and cost. But thus far, we have not seen that taking place, even in a sort of a current and post-COVID environment. So that's encouraging. And utility incentives for ultra high performance buildings, which is enabling passive house levels of certification and construction, as well as net zero and carbon positive buildings, is being rewarded in ways that we haven't seen before. So this is just a look at Mass Save's incentive for mid and high rise residential buildings. And there's incentives for non-certifying projects as well as certifying projects. And if you do certify, you're looking at approximately $3,000 per unit, plus some of the soft costs for the investment, or the exploration into the investment. But I think that the real benefit here is this performance bonus. So you're looking at 75 cents a kilowatt hour avoided, as opposed to typical utility rebates, which are, you know, somewhere between, you know, they max out at, I think 31 cents is my last count, somewhere around 30 something cents if you do a very high performing building, but they're typically in the 20 cent per kilowatt hour avoidance range. If we're going towards this level, it ups the ante quite a bit. And the $7.50 per therm can be avoided if we do an all electric building, which is sort of the long-term goal of the city and other municipalities that are trying to electrify and transition toward a new renewable energy grid. And in a heating dominated climate like we have here, that $7.50 per therm avoided could be a huge payday for projects. And also rating systems have started to pick up language that's less about doing less bad and more in moving towards this carbon positive and net zero energy future. And we started to see, you know, used to at the beginning of the decade, LEED dominated the conversation. And now there's an ecosystem of various different rating systems that are out there that represent this spectrum of possibility. And sort of leapfrogging LEED, you're starting to see elements like Passive House or the Living Building Challenge, which aren't anywhere near the market share of LEED, but they're starting to gain momentum as tools to achieve net zero energy construction and to be rewarded for it. And so, for example, LEED has created the net zero certification. FIAS has created the FIAS Source Zero certification for passive house projects that are adding geothermal and or solar in order to achieve zero carbon emissions. And then even the Living Building Challenge has dialed it down a little bit to have this zero net energy certification as well as a carbon-free certification as well. So the third-party rating systems are starting to develop tools and programs and language for projects that are seeking to focus on just energy and maybe some other sprinklings of other elements of the rating system. They're starting to bring recognition to those projects. We're just seeing a lot of money invested in this, and this trend has continued to rise. And so, you know, the idea is that the market is shifting away from a smorgasbord of bad performing bad performing products towards products that more handily help us to achieve zero energy construction. The technology is also becoming more approachable. So I just think this from an aesthetic standpoint is important. Now, I, for one, like the image on the left-hand side, but I would say the majority of the designers at my firm and clients that I have don't necessarily think that's the most beautiful thing they've ever seen. I think it's encouraging to see, you know, someone like Elon Musk working on this problem. And so now we have Tesla battery storage systems for every home, Tesla on-site solar shingles, and even solar carports and driveways. So I think as the technology becomes more approachable and more familiar aesthetically, I think that it will get more buy-in. In particular, linking the home as a part of the system. As you saw in the sort of the future smart cities diagram, this is a transitionary step towards doing that for the typical consumer, which I think is an area that we typically don't hit to our non-benefit. And capital D designs. So I think that, I love both of these designs, and I love and admire the work of both of the firms that did these projects. So the one on the left to me, though, was done earlier in the decade. This is an Architera project out in Western Mass. And I think it's a beautiful project. At the same time, it's a project that reeks of being environmentally sustainable, for better or for worse, arguably. I think that's cool. So I'm not trying to diss it for that. What I'm trying to say is that we have transitioned away from an aesthetic that has to be that in order to be ecological, towards one on the right-hand side where we have, this is an AI, and both of these are AIA Top 10 award winners at various different years. This project on the right-hand side is a project in DC by Payette. And what's interesting about these two images is that you have one that sort of spells out sustainability with a capital S, and that's fine. And on the other side, you have one that looks like it's a high-tech, modern, desirable, cool, hip space. And that's cool too. So you have this sort of transition towards capital D design that now encompasses sustainability and net zero. You also have the collective behaviors of AIA firms and members and organizations working towards this goal. Although we haven't gotten there yet, we've sort of hit a stagnation point at around 40 to 45% reductions. When today in 2021, looking at 2022, we should be at 82 to 84% better than code today, which means 2009. So we're starting to see renewables ramp up more, but we have to continue doing better. And I'm not here to point out any flaws or to say that the AIA 2030 commitment hasn't been successful. It just takes time to build the energy literacy to be able to transition the culture of firms to be able to embrace this. And the AIA signatories are the firms that are doing this, and it doesn't necessarily represent the lion's share of all AIA members, but these are the firms that are leading the way. Speaking of which, the firms that are leading the way and the firms that are consistently winning the AIA Coke Top 10 Award, as well as which are meeting the AIA 2030 commitment. So some firms are doing it. So if the average is 44%, some firms are exceeding this 84%. And back in I believe it was 2016, 2017, these firms got together and under the leadership of the AIA published these two seminal studies, The Habits of High Performance Firms and Lessons from the Leading Edge, to share the secret sauce, so to speak, behind how they consistently have ingrained this both in their culture and continue to win these awards, report what they do that's unique to them in hopes that other firms would adopt some of these leading edge practices. And so these are free documents that you can download and share with your constituents to be able to emulate some of the success of these firms like Lake Plato. That's the one that comes to mind. I think Perkins and Will is another one that has won many AIA Coke Top 10 awards, and they're basically telling you how to do it, which is pretty wonderful. And then lastly, in terms of why, and I know this is a very long introduction, but I think it's worthwhile to paint a portrait about how far we've come and as an industry, but where we're going. And for the next generations, we're starting to see the young folks questioning us in ways that we never had before. They're not accepting that this is just the way that it's done. And, we always say that we're doing it for them, but they're starting to hold us to that. And, my buddy Greta is one to point the finger at adults that aren't living up to their promises. But I think that we have to contextualize this in terms of not only we doing it for them, but they are now asking us to demanding that we follow through on these actions. And so this is important for people of this age, and younger practitioners in your offices who get discouraged when they see leaders backing down from, aggressive targets like meeting the AIA 2030 commitment. So I think that in order to remain relevant as a practice, we have to think about how we're building these buildings, who they're going to be for, how they're going to be used. Otherwise, we're gonna be judged in the court of social media, which nobody wants. So to finalize the introduction, is it getting easier? Well, in some ways, yeah. So we're seeing falling costs, we're seeing codes increasing, we're seeing equity, resilience, health driving the process. We're seeing mission-driven clients showing up. We're seeing healthy competition as well as sharing amongst practitioners. District scale solutions and smart buildings are starting to become more the norm. It's no longer this sort of newsworthy, like, wow thing. It's just, it's available to us and we're using it. I think that with the shorter payback, the wider synergies and the deeper awareness, we still haven't necessarily captured the minds of the public yet. I think that we still need great architecture and design and spokespersons and education around this in order to hit our target audience. But the traction is there, and it's still a work in progress. So there is still great financial and political uncertainty around this. There is still the market preference for deep floor plates as well as maximum glazing. And that's always going to be a challenge, especially in speculative environments right now, where we're designing, highly flexible, could be office, could be lab buildings. We're all doing them right now, right? There's other issues associated with some of the challenges, which, there's the desire to electrify, but then there's the reality of doing that. There's also some confusion around what are the incremental steps that projects need to take in order to be future ready, but not sort of leading edge and risking failure or risking putting away tenants because of the costs and or limitations built into the building. Passive house in all of its glory is still coming in at a very high cost premium relative to your traditional, developers, and that's presenting some challenges despite the fact that it's very desirable in many cases. And I'm just gonna throw this out here. We're starting to see all of these studies and all this level of complexity added onto projects that are more than code and more than what's written down. And the reality is, and I'm guessing that my majority of my audience here are architects today, and you're all experiencing the same thing that I am, is we're seeing the disappearance of schematic design and fees that are way too competitive, asking for miracles on very little fee and very little timelines. So we're having to do more, quicker, faster, not just in terms of to save to reduce carbon emissions, but also just in terms of typical project delivery. I mean, I joke now when I hear that we're on a fast track project that I don't even know what that means anymore, because aren't they all fast track? And I think that's a real challenge, because the reason why is because we want to front load the process in order to get performance evaluations of various different options and pricing and all this information, so that we can move forward into design with all that baked in. I think the zero carbon assessment that the city of Boston has published has helped us to do that. It is always, though, a challenge to get it in time before the design becomes set. And I think that that's going to continue to be a challenge until clients realize the value of allowing time at the front. So we're going to take the lessons that we just learned and see now how they have been applied over the course of a decade. So this is sort of the lessons learned from a decade part. These are two projects that, in my mind, illustrate the transition from early in the decade from sort of mission-driven clients towards the latter half or the latter end of the decade and today, which is the movement from mission-driven clients to mass market clients. The project on the left is it was completed in 2011. It's the National Renewable Energy Laboratory in Golden, Colorado, which is one of our projects, not the Boston office, but our Denver office of projects. And it was a net zero energy facility, AIA Code Top 10 award winning LEED Platinum project. And then on the right-hand side, this is the Evolve One project, which is in Waterloo, Ontario. It's a LEED and CITES Platinum project. It's our first carbon positive certified building in our portfolio. Very different climate, deep floor plate, and speculative developer building. So proof that it can happen in a difficult climate with a developer pro forma. So I'll pause right there just to see if anyone has any questions about where we're going to go or what we've just presented, or any comments on anything related to this topic, or anything else for that matter. You guys are shy today.
Blake, I'm not shy. I just wanted to ask if you could quickly give an overview of the status of technology on battery storage for large scale on-site PV projects. We're having a lot of issues with that on our end.
I mean, the status of them is that they're large and expensive and heavy. And, you know, that's the challenge that we run into in all of our projects, and especially because we're doing a lot of urban projects. It's difficult to find space for them under the current norms because space is at such a premium. And, you know, you can't just say, oh yeah, we'll put them on the roof someday. I mean, these things are the size of an RV. So you've got to figure out ways of getting them up there. You've got to have the infrastructure in place to absorb them. And you know, frankly, what we're hoping for, and what I'm starting to see with some other clients that I work with. So I'm working on some confidential manufacturing projects right now, and I'll just put it out there that the batteries of the future will be much lighter and much more easily adaptable to the realities of existing buildings, which the current battery technology just really isn't, because you need structural loading. You know, there's a lot of infrastructure that needs to be put into place. We've been we've been utilizing Boston's Smart Utilities Policy Program for some of our large master planning projects. So basically anything larger than 1.5 million square feet, we have to do a microgrid feasibility study, which looks at on-site solar, on-site wind, battery storage, electric vehicle parking. There's a few other things, geothermal. There's a bunch of different systems that we look at. And we have to have load profiles, which means that there's energy modeling that's run, as well as the building is basically designed to at least a DD level before we start evaluating this. And even for large scale developments, we're not seeing the numbers pencil out in a way that works for developer performers yet. And we're sharing these numbers with the BPDA, and they're coming back and acknowledging that, yeah, the numbers don't work. You know, we understand you're developers and you're not looking for, 14-year paybacks on technologies. But again, what we're having to do is say, well, the technologies will do what solar did and what LEDs did. It just takes a matter of time. So we just have to plan the infrastructure in place today to be able to adapt to them whenever that dynamic changes. And at some point, we anticipate that developers aren't going to be made to do this anymore. They're just going to want to do it because it's going to pencil out. And so we're just planning strategic areas either on the roof or in a basement, as long as it's protected, or within parking structures, which we're hearing that parking structures are going to be less necessary in the future because of autonomous vehicles in downtown urban areas. So what are the uses for parking structures above and below grade that could enable them to be adapted to this future, and also future uses? So we're throwing out crazy ideas like, well, that underground parking area would make a really great place for battery storage and a bowling alley, and just things like that. We're starting to get very creative with it, but the idea is that you plan ahead for these things. And, the technology will be the same for a while, but then it will also shrink and get smaller, both in terms of cost and in terms of space and weight. And I think that once that all comes into place, we're just going to have a battery in every building.
Blake, this is Peter Papesh. I have a couple of questions. Prospects for DC grid replacing the existing AC grid, and perhaps this is a follow-up question on the battery storage idea, thinking of microgrids and combining those with DC, new DC grids that replace and enable the replacement of all the AC converters in buildings to an all DC system in the new buildings. It's a bit of a reach, but you want to comment on these ideas?
Oh boy, you get out of my comfort zone now. I'd rather ask one of my electrical engineers about this particular question. What I do know about this is just from experience at running into this problem on projects where we're trying to. There's a project. I'll keep it confidential for right now. I mean, every project now is a confidential project. But anyhow, just so I can avoid a lawsuit this week, I'll say that I'm working on an existing building which has a rooftop which is absolutely ripe for a solar retrofit. And we're even going back, and the building fabric is at a stage where it needs to be retrofit. So it needs a new roofing membrane anyway. We're going to rip off the roof. We might as well put some more insulation down, structure it accordingly, and put the solar in. Now, it was a slam dunk in terms of finding a solar provider who was willing to work with us to get a power purchase agreement, and everything penciled out, and everyone was happy. And then we started looking at the existing switchgear in the building, and we realized that for us to be able to wire the building for solar was going to create this massive upgrade to the switchgear box. And it was going to have this ripple effect throughout the building. And it was this enormous hidden cost that now has sort of taken the solar project back to ground zero, so to speak. And its future is uncertain because of this issue. And the other issue too is that they know they have to upgrade at some point in the future. They just don't know if it's going to be now or if it's going to be in 10 years, because it's a phased renovation of this project. And so it's a pity though if we miss the opportunity to put the solar on the rooftop, because the issue is that once the membrane is down and the insulation is down, the warranty for those products begins.
Cost.
Yeah, and you don't want to create a scenario where you have a new product in 10 years on top of something that's halfway through its warranty already, and then it voids it completely when you alter it. So, those are just some of the challenges that we are discovering as we go. And I think that in terms of the existing buildings, it's not going to be as easy as just putting solar on the rooftop for some of them.
Thank you.
Which is really a pity, because it doesn't take a rocket scientist to say, hey, we got this huge rooftop asset. Why don't we quit making it, why don't we quit allowing it to be lazy? Why don't we put it to work to do something? Capture stormwater, make money for us, provide carbon-free power for 25 years. And it shouldn't take the level of difficulty to achieve it as it sometimes does. So, just a bit of my frustration there.
Go on with your case studies, because I'm sure more questions will arise.
All right, fantastic.
Thank you.
Fantastic. All right, so let's talk about the first decade. So this is a little bit more of an introduction, but just it gets us to where the NREL project, or the National Renewable Energy Lab, comes into play. So the early adopters for this were in the early 2000s, and most of it happened to be around sort of buildings that were perfect for net zero. So Southern California schools, visitor center, buildings like that, which had a low load profile, low energy use, highly forgiving climate. And the idea was to move into this proof of concept and to see if, and this was being driven mostly by mission-driven clients, such as schools or, trustees of a park or something like that. And the government picked up this idea both at the local and the national level to say that, okay, we understand that the technology is untested and is too costly relative to where codes are today, say in 2000, 2005. So the idea is that we need proof of concept, And so we're going to infuse money and funds and technology and expertise into this to see what we can get out of it. And so you started to see this series of projects that transitioned away from just those one-offs to these sort of big proof of concept projects. And the National Renewable Energy Laboratory, or NREL as I'll call it through the rest of the presentation, is one of those such projects. And this is a very sizable building. So notice the jump in scale from the little visitor center to this building. And this building is a LEED and Sites Platinum project. It's suburban in its location on previously developed land in Golden, Colorado. So it's sort of a high desert climate. So it's a high altitude, dry air, cool climate. And roughly 222,000 square feet. And the cost came in at that time when it was completed in 2011 at $288 per square feet. It's intended for 822 occupants for 50 hours a week. And at the time, they were transitioning the research staff and the admin staff out of private offices into open office. And this was to spark innovation and collaboration. This sounds very familiar to us today, but at that time, this was sort of a unique situation. The idea behind the building was to enjoy the bucolic nature and to enhance access to the climate and nature. It employs water conservation strategies, which reduce outdoor water use by 84% and indoor water use by 55%. I like this quote, which came from Rachel, my discipline lead, who was working on the project with Porus, who was the energy modeler. And from that conversation with them, we determined that, there was this philosophy in this building because it was so cutting edge that every decision had to have an energy consequence. And one of the consequences was the resultant building form in the shape of an H. And so the idea is that you have this very European style Class A office space, which is 60 feet wide bays of column-free space, which are both naturally ventilated as well as have a 92% spatial daylight autonomy. The materials are utilized for both their LEED certification purposes, their regionality, their recyclability, some salvage material, as well as their ability to store heat and or cool via the thermal mass and the thermal inertia of the materials. They utilized a series of innovations. And again, this is a mission-driven client whose goal is to promote renewable energy research and technology. And so they have a solar wall, a thermal labyrinth, integrated PV, an underfloor air distribution system, a building dashboard, and even electrochromic glazing. And we'll talk through where these show up in each one of the components of the building. The modeled EUI was 33, the verified EUI was at 33 kBq per square foot per year. And the PV was sized for an additional 2 EUI, just in case, because they really did want to make sure that they met this net zero energy target. So the PV is actually oversized for the building. And the lighting power density for this time, and they didn't use LEDs because they were not deemed necessarily very cost effective at that time, was 1 watt per square foot, which is just a little bit above what code compliance is today at 0.9 watts per square foot for office. So this is a look at the campus plan, and this is that H-shaped connector that you see. And as you can see, plan north is true north in this sense. And so what they've done is they've maximized their south exposure. They've built this in a way that minimizes the north exposure and also the east and west exposures while creating these sort of indoor courtyards off this central connector of the 2 north and the south wings. And a little look at psychometry just begins to talk about the incorporation of passive design strategies, which enabled them to reduce the need for cooling systems in the building through these various different strategies of expanding the comfort zone, such as evaporative cooling, indirect evaporative cooling, natural ventilation, and thermal mass. And even the space planning that they utilized was in order to maximize this benefit. And so I apologize because the plans, and particularly the large one, reads a little bit like these are walls. These are actually just, most of the spaces are actually open office that have cross ventilation and or single-sided ventilation on both sides. So very open spaces that allow a lot of light in, a lot of air to come into the spaces. And notice they've oriented the open spaces toward the south so that they can maximize the daylight penetration. And they've done so on every single level. And notice that the building actually grows in a way that has more bulk to the north and to the south. And part of this was to maximize the roof slope in order to gain efficiency for the solar panels on the rooftop that were built into the space. And this is just a look at the building section. And you can see here that the rooftop on level 3 and or 4, depending on which bar you're looking at, is angled in order to maximize the solar efficiency, also to help to collect rainwater. And because they wanted to maximize solar efficiency on the roof to hit this EUI target of 35, they needed very small systems that compactly fit within the building footprint at level 1. And so you see that here. They employ a great deal of passive and active systems. So you have cross ventilation on the upper floor where the majority of the open office spaces are. You have single-sided ventilation on level 1 and 2 here. You also can see the use of extensive solar shading in operable windows to minimize the need for cooling systems, as well as to redirect diffuse light within the space. And you also see the utilization of underfloor air distribution systems, as well as the thermal labyrinth. You can see it sort of in the foundation zone of the building. And you know, we found that underfloor air distribution systems, which is a very common system in Europe, and also here as well, but much more so over there, it's a more energy efficient means of ventilating, heating and cooling a space, but it's also a healthier means of ventilating the space because you're introducing the air in a way that's very flexible that allows for the individual occupants to control it through the use of in-floor diffusers, which we'll look at some photographs of in a moment. But again, there's a lot of strategies built into this building. What I like about it is that it's very simple, actually. It's not an overly complicated building where they threw everything at it. They've actually made a very simple building that's more about the architecture than the life support system that supports the architecture, which is fundamentally different than how like a code compliant building would operate and work. And then this is just a look at that same section, but relative to the overall building to show again how each facade has its own fenestration. The idea of this open office is reinforcing the idea of cross ventilation as well as daylight from two sides. And you see that they're using the bones of the building or the structural mass of the building as a building system as well, utilizing air to flow down the core into the thermal labyrinth and then up into the air handlers, which we saw previously in the section diagram. And you also see a minimized exposure on the east and west, so very strategic openings and or porticos to shield the east and the west parts of the building from excess solar exposure and gain. And on the south side of the wall, you see a thermal labyrinth, which also is utilized to preheat air going into the the solar wall, which preheats air going into the thermal labyrinth, which then moves into the level 1 air handler for distribution into the rest of the building. So a lot of really interesting technologies, which we're going to see creep up later on in some of the later buildings. And we talked about fenestration. And as you can see here, there's no solar protection on this north facade over here on the left-hand side. If you look at the line down the center image here, you start to see the south facade, which is highly protected both on the east and west and has a light shelf to minimize the effect of the high angle sun. So it hits, shields, and then redirects up to the ceiling. And then on the east facade here, which we're looking at, what we did was we put very strategic openings to minimize the east and west exposure, but this happened to be where the view of the mountains was long distance. And so we didn't want to take that view away from the occupants. And so what we did was we recessed occupied space to create these indoor-outdoor rooms, or these sort of balconies, where people could gather, they could go out and work, go out and have their lunch. And in these strategic areas on the east and west facade, we incorporated at that time what was a new technology, which is electrochromic glazing. And it's a very expensive technology, which basically means that an electric current runs through the glazing, which tints the glass at certain times of the day or year in order to reduce the amount of solar heat gain coefficient in a dynamic way. And so in order to maintain the view for the time when the sun wasn't problematic, we incorporated a very expensive technology, but in a very strategic way in order to manage the cost. And I think a very clever way, but which otherwise doesn't put blinders on the building for whenever the view is there to behold. This is just a look at the south fenestration. You see the solar wall with the protective fins on the south facade, the typical south facade here on the left-hand side. You see the effectiveness of that on blocking direct solar gains on the inside of the building. And also the materiality was very much local and of its place, and trying to sort of relate to the microclimate and xeriscaping techniques. And again, trying to make this a modern building, but also one that fits into its place as well. And these may look like the most generous open office, single occupant desks you've seen in a long time. But again, this sort of was the transition from, and this was, part of the reason why they were able to convince people to come out of their private offices and move into an open office working environment through these generous spaces. Certainly they'd be much smaller today. But this shows the 60-foot wide span on the third or the fourth floor, depending on which wing that you're in. And as you can see, there's light on two sides. They utilize high and low openings to be able to naturally ventilate more effectively. And because there's no obstructions, light and air are able to move through the space very handily. They also have a building dashboard that tells occupants when they need to open and or close the windows based on the temperature and the settings and the humidity outside. And I like this image also because if you look at the bottom center, just above the W, you see the diffuser there. And the diffuser is basically just showing how the underfloor air distribution system works so that each occupant has access to control the amount of airflow and direction that they are or are not receiving, which is a very, which ties into the adaptive comfort theory that if occupants have control over their environment, they will seek out scenarios at which their comfort is maximized. And so this plays into the idea of a healthy building, and many of the adaptive comfort theory ideas that come from Europe have found their way into the WELL building standard today. So this building to me is really summed up in terms of an understanding of climate literacy, form and technology in addressing of behavior and awareness within the occupants. And what better occupants than researchers in renewable energy technology to have. And this building, and remember, it's a H-shaped building with a lot of expensive perimeter at the cost of less expensive, less sizable, more simple mechanical system. And that building is based on what I call the Nordic model. And the Nordic model is predicated upon passive design and the adaptive comfort theory, and it can show up in many different forms. So for example, this is another Nordic model building in Dessau, Germany. So this is the environmental headquarters of Germany. It's basically Germany's EPA headquarters is this building, designed by Sauerbruch and Hutton in 2005. And it looks like a very deep plan building. But if you look at the plan of the building, it's actually a long, slender, 60-foot wide building that wraps around this very strange post-industrial infill site. And it's a double loaded corridor with individual rooms off each side, which are designed around the Subsidy guideline for geometries on natural ventilation and daylighting. And each one of these windows here represents a various different office or conference room so that each one of the occupants has an operable window and controllability over their light and airflow. And I can tell you, I lived in Dessau for some time. They have worse weather than Boston. So it's nice also for them to have this indoor space that's enclosed and naturally ventilated in order to sort of create these collisions and this sort of health and well-being element, and to be able to be outdoors when it rains seemingly 300 days a year there in Dessau. But a rather complicated building from the outside, but you get inside and it's a very simple building that's just a 60-foot wide Nordic model building that wraps around this enclosed courtyard that's coupled with the outdoor environment, but is sort of created a bit of a winter garden, a passively designed winter garden. And if we look at the geometries that enable these types of passive design buildings to happen, we can reference the Subsidy guideline, which is essentially the internationally referenced guide on natural ventilated buildings. And if you look at ASHRAE or LEED, or even the well building standard, they all reference Subsidy. And so these geometries that enable both daylighting and natural ventilation are mutually inclusive of each other. So what you're doing one, you're doing for actually both. And so here, for example, in the corridor scenario of a single loaded corridor, if you have a high and a low opening, you can allow for a deeper effective natural ventilation or a convective current to happen within the space. If you double load this and turn it on its side like we did at NREL, this is where you get those 50 and 60-foot geometries, and why there's a lot of alphabet-shaped buildings in Europe, in Scandinavia, Germany, Holland, et cetera, is because of these geometries that are given by the Subsidy guidebook for single-sided and or cross ventilation. And so this was very much in our minds as we were designing the NREL headquarters many years ago. And it's why we settled on a 60-foot wide H shape so that we could cross ventilate, single side ventilate on either side, and have a greater than 90% spatial daylight autonomy within the space. And this dimension is true all over the world that is utilizing what I call the Nordic model. And I call it the Nordic model because it is building code in countries like Germany and in Scandinavian countries, that an occupant cannot be further than 6 meters from an operable window. And these are very humanistic building codes and design guidelines, which I think that have driven passive design in low energy buildings for a long time. And it's part of the reason why you haven't seen developers jump on this yet, because it does preclude the ability for the types of spaces that we are designing in modern buildings for healthcare and labs and other types of buildings. Now, that is going to change in the next model, and we'll talk about that in a moment, but I just want to pause and see if there's any questions or comments or thoughts on what we just presented, which was sort of the first decade of the net zero energy building.
You have about 25 minutes, Blake.
Plenty of time. So let's get into this, and then we'll summarize it at the end. We'll save some time there. So this is a very, very different building. This is the Evolve 1 project in Waterloo, Ontario. It is a developer project in a cold climate and lots of parking. It's a regular form with a deep floor plate. Very different building from NREL, although you can see already there's some of the characteristics of the DNA of net zero energy building that we learned from NREL that show up in this building 10 years later. So it is this is a LEED Platinum carbon positive building, and it's developer driven in the Ideas Quarter of Waterloo, which is a new, sort of a new innovation district. It's suburban on previous developed land, 1 acre in size. And the goal was to create Class A space at local market rates so as not to price out the types of tenants that they wanted to attract. It's about half the size of NREL. It's 104,000 square feet on 3 floors. And the goal was to be able to subdivide the space and or lease out the entire building if desirable to a single tenant. So developer flexibility all day long. They were predicated upon this idea of open office and also being adjacent to rails, as well as 2 of the 5 Canadian top universities within this, adjacent to this area served by this rail. Has on-site EV charging. It's adjacent to bike paths. It employs a rigid water conservation regimen. It had actually wanted to be water neutral, but that became a bit too, it basically got priced out. And at some point we had to make some decisions. And so we did very innovative water strategies, but we didn't go all the way neutral. Talk a little bit about that at the end if we have time. There's many amenities in this building to sort of attract tenants to it. So there's a 5,400 plant living wall, a feature stair, dimmable LED lighting, locally owned and managed cafe, a convener space. The solar electric charging for the vehicles is free. It's adjacent to a park, and a fitness center is being phased in. So this is part of a multi-phase project. This is phase one. And there's 1,440 PV panels on site, on the rooftop, and in the parking areas. The building has a developer depth and flexibility. So it had to accommodate various different types of use types and tenant types and loads in order to have flexibility, which is something that's very important for these types of buildings. And the material palette is very simple. It's just metal panel, fiber cement rain screen system with glass curtain wall. I think the innovative component of this building is not necessarily any one strategy, but it's the fact that we just found innovation through the bundle of strategies. So there's just a lot of strategies employed here, as well as processes that are unique to this project, which we'll talk about in a moment. And the real way that this all pulled together is that the developer, instead of allowing the tenants to come in and develop their building, their spaces any old way that they wanted to, they sold turnkey space. So they were able to control the lighting levels, the ventilation rates, the VOCs. They were able to control the tenant package in a way that enabled them to deliver on their promise of maintaining this as a net zero energy building with flexibility in mind for the tenants, which is unique. I mean, this is a green lease in its purest form and something that you don't see a lot of, but it is becoming a bit more common. And the building was designed for an EUI of 21 with a PV size for 22. And again, as you can see, this is a common theme of oversizing the PV and being able to either store or sell the energy back, or having a bit of an insurance policy just in case you're using more than you plan on doing. So this is just a location plan adjacent to the university, and you can see that the building is located here in orange, adjacent to the rail connection. And you can see the rail connection right there. This is the site, so it actually has quite a good solar orientation, and something that we were able to take advantage of on this suburban site while including parking. And as you can see, this is phase one of a two-phase development, and phase two, I think, is just going to be a kind of a carbon copy of this one. It may have some subtle nuance difference to it. I haven't seen the design of it yet, but you can see here, they've foregone the H-shaped building or the V-shape or the U-shaped building for a deep, flexible, typical developer, 120 by 350 feet floors. And the deep, flexible floors are what makes this building work for the various different tenant types that they want to attract. And I think it's great in terms of how, this is not a dig at the project, but in how unremarkable this is. I mean, this is a typical developer product. And to think that we can actually have that and net zero or carbon positive buildings is to me extremely encouraging, that we don't have to have alphabet shaped buildings anymore. Although I love them, they don't fit every pro forma. And so the fact that we can have deep, flexible floor plates that are appealing to developers and tenants alike is encouraging. And this is just a look inside of the building. So this is the communicating stair that connects all three floors, common spaces on the ground floor, the 4,500 plant living wall system there to the right-hand side. Very simple materials, again, and the fenestration is very similar to NREL in the sense that every facade has its own unique articulation. So on the left-hand side, you see the north facade with the east-west facade with the vertical bands and minimal glazing. So the most glazing to the north. On the right-hand image, you see the south facade. So it has some reduced amount of shading, as well as this architectural fin, which helps block some sunlight and direct it into the space, as well as placing the PV canopies to the south to shield the parking area from absorbing all the sun's heat. But this is one of the elements that is one of those DNA elements within the net zero energy construction over the course of a decade is each facade has its own unique articulation, as well as you can see here, the bit of a differentiation on the south facade. You can see the solar wall there, which is also something that we incorporated on NREL. And so this preheats air on the south facade, which moves into the air handler to give it a little bit of a boost relative to just simply pulling in direct outdoor air. And one of the other things that we did on this project was we really focused on minimizing the glazing, which is not typical for developer product, but to show that it can work and to incorporate a very, very airtight passive house compliant envelope. And it doesn't mean that we can't have curtain walls. So you can see here we have punched openings for the leased space, and we have a curtain wall system which maintains our continuous insulation in and around the spaces because it's thermally broken and it moves inside of the space to maintain that continuous insulation. But it's to say that you choose your battles with glazing and you just put it strategically in areas that it wants to go. So here, this is on the other side of that 3-level atrium where the living wall and the communicating stair is going to go, and there's bridges that move across which open up a view to the south. And this is why we created that sort of designation of you've arrived here in this one strategic area while focusing on the airtight envelope in the zones that will be leased. This is just a look at the extensive water conservation that we utilized on the project. And again, we offset 80% of indoor water use. We used rooftop water for irrigation and toilet flushing. And this is a look at the turnkey space. So again, this isn't exactly Spartan space, but it's startup space. And this is exactly the type of tenants that they wanted to attract. And again, this is done through a green lease where they're giving them a kit of parts and they deliver turnkey space, ventilation, paint, lighting levels, plug loads. Everything's under control of the developer so they can deliver on this promise of this building being a net zero energy and a carbon positive building. And so it doesn't have runaway energy use like you might have without a green lease. And the project for this has won many awards, most notably being certified as a zero carbon building. And this was the first in our portfolio and hopefully the first of very, very many. And with that, I want to talk a bit separately about that in terms of process. We've presented both of these in terms of their process, in terms of what they are as artifacts. But this part 4 and really the conclusion is what are the processes that enabled us to move from from mission driven to mass market? And we all know that conventional buildings have a low price tag and a high operational expense. And the goal of sustainability for a long time was to figure out where that inflection point was with being able to absorb the initial costs with the promise of long-term operational savings. And working in an integrative process is one way of helping to alleviate that issue. And on this project, we were fortunate enough to own all the scope. And that's one of the this isn't meant to be a sales pitch, but it is one of the benefits of being a company that does everything is that you can own everything. And so this was a collaboration between 5 different offices, everything from architecture to geothermal engineering and solar engineering and everything in between. And this was a 3P process as opposed to sort of the linear process that we have that doesn't facilitate integrative design. And so cost, performance, everything was worked out from the beginning. This is more typical here in the US for institutional work or very large complicated projects like healthcare. In Canada, this is more the norm for various different types of projects. And the goal is to really turn the process on its head to say, well, what are the tenants' strategies? And looking at who we want to attract and what would attract them. And that sets up our load. And then what are the passive strategies that we can employ? Is helping us downsize our use. And then what are the active strategies that we can employ? And then whatever we can't get rid of, we have to do on site through renewables, as opposed to the opposite, where we just sort of start in a very, we just sort of strategically place these things at points in time and they're more like applique. The idea was really thinking about the process backwards from the endpoint so that we can minimize renewables instead of having to have fields and fields of renewables. And this is a comparison of code compliant version of Evolve 1 in Evolve 1. And as you can see, there's drastic drawdown in terms of lighting power, space heating and cooling, fan power reduction, service hot water heating. The plug loads are the same for both the base case and the end result. And again, that's just because that's how you do energy modeling. The only area where Evolve 1 uses more energy, but not more relative to the savings that you get unilaterally across all the systems, is in the pumping power. And so this was the pumping power necessary to enable the geothermal exchange system to happen. And when you're looking at energy use in ultra efficient buildings, notice the standard building, lighting, heating, and cooling are sort of the big three. And especially in this climate, it's going to be space heating is going to be driving the performance of the building. When you drastically draw all that down, suddenly the plug loads become an area of focus. Notice the plug loads in Evolve 1 are nearly half the overall energy end use of the building. And this is part of what predicated the client to enter into a scenario where they delivered turnkey space through a green lease so that they could control the plug loads from not just running away with and the building forfeiting its goal of carbon neutrality. And this is just another look at the process again, where we're maximizing passive strategies, active systems, so that we can get to very refined on-site renewable systems. And we were able to do this by incorporating a new practice called parametric analysis. And a lot of times we're seeing parametric analysis take place in the design arena through, if you think of the architecture of Zaha Hadid, for example, that is a practice which is very heavily focused on parametricism. But it's been employed more for design than it has been for energy. And one of the goals of parametric analysis is to be able to manage all the different variables that are driving performance in a building. And so what we did was we leveraged parametric energy analysis with real-time cost data through that circle of friends that we established to help us overcome the sort of dart game of looking at various different strategies so that we could arrive at bundles that worked early on in the process. And so this is every possible strategy that we could have employed. And what the parametric analysis enabled us to do was to zero in on the individual options that actually met our goals, both in terms of performance and budget. And some may be frightened by this because it feels like perhaps we're letting the building be designed by the computer. And that couldn't be really further from the truth. What it's actually doing is it's helping us hone in on the goals of the project and the options that meet them and that we can afford. And so this rendering on the right-hand side is just an early look at what we thought Evolve 1 was going to be. And so there still is a need for design professionals. The goal is to eliminate options that don't work so that we're not wasting our time, and to acknowledge this fact that we're being asked to do more quicker. And what we did was we honed in on these three options for building performance, and then zeroed in on option 3 because we felt that that gave us the best ability to meet the goals, the best flexibility, and the best price. And so we ended up working with a VRF system with a central heat pump and geo exchange with R30 walls and R40 roof. And notice that is a much more expensive envelope than option 2. But the radiant the radiant slab system didn't enable the type of flexibility long-term that we felt would be viable for the building. And perhaps if the tenants wanted to cut holes in the floor, or they wanted to bring in equipment or do some light manufacturing, we felt the radiant slab wouldn't be able to hold up from a long-term flexibility stance. It's a better system for a purpose-built facility than a flexible facility, which is part of the reason why we moved towards VRF. And this enabled us to fully electrify the building as well. And so anyhow, just in the interest of time, we still also had to, work out the design of the array, whether it was going to be all on the roof, whether it's going to be flat, whether it's going to be in the parking lot or on the field, or all these various different things, and also getting down into the technicalities of the glazing spec. And so again, the parametric analysis isn't designing the building for you. You have to input the parameters such as height, shape, floor to floor, material. So it's not getting in the way of us designing. It's just helping us deal with the complexity so that we can narrow down our options and focus to things that provide value. So if used properly, can actually save us time and allow us more time to design in theory. And these are a series of the 17 strategies that we had originally employed on the building. And as you can see, much of this is very similar to what we did at NREL. So here we have a geo-exchange system, which was unique. We have natural ventilation, we have a solar wall, we have strategic fenestration attuned to each facade. We have on-site solar, on-site water storage. We had originally wanted to have a living machine, and that was going to be the thing that took us to zero water. But we found that, even though we were able to run these parametric analyses, we still had to mitigate cost, schedule change, things that every project has to encounter. So 4 of these projects didn't make it in. We ended up not doing displacement ventilation on the ground floor. We didn't do the thermal labyrinth. We nixed the living machine, and we changed out the domestic hot water system for a more cost-effective solution because the sudden shift away from the zero water goal. So again, we had to make some tough calls in this project. It was a developer pro forma that had to not price out tenants that they were hoping to attract. But again, we worked a lot of systems into this building. So a geo-exchange, high efficient HVAC systems, which are all electric, and building envelope commissioning, which is super important. And so this is sort of transitioning into the closing. And I know that we've got about 5 minutes left. So I just got a couple more thoughts before I turn it back over to you guys, is just to say that this can be done on a developer pro forma if you employ the right team and the right tools. And also if your client's willing to indulge you. But lessons learned from a decade, where are some of the areas where zero energy buildings can go wrong? Well, certainly in terms of the envelope. And so technologies, but also commissioning of the envelope is hyper important. Understanding the use of the building. So this was another one of those early net zero energy aspiring buildings that didn't quite make it. And what happened to this building was that it ended up having more staff than was planned. Technology shifted towards more computers and more personal devices and things that weren't necessarily planned for. We found that they weren't cleaning the PV system regularly enough, and that was impacting the PV production. And essentially the building just had greater loads than modeled. So this is a very energy efficient building that almost got to zero energy, but it missed the bar because of some of these areas of occupancy use and also maintenance that were lessons learned when through tracking and staying engaged with these buildings. So in summary, keeping buildings simple, maximizing passive strategies, utilizing parametric analysis, in particular sub-metering, maintaining the buildings, and not throwing out holistic efficiency, still considering indoor air quality, water, transportation system, et cetera, are all important recipe components of zero energy and carbon positive architecture. And with that, I will conclude. Thank you guys for having me back, and we can spend some time talking about this if you've got questions, comments, or thoughts.
Just to thank you very much, Blake. I'll open it up to questions for everybody.
Peter, there's a question from the chat. So what percentage of budget we should have to make the building energy efficient?
That was
Ballpark.
no. That's a great question. So notice I didn't present that, and it's a number that doesn't exist for NREL. Oh, actually, sorry, for NREL or Evolve One. It never existed. There was never this question of, well, what do we have to do versus what are we gonna do? And I think that's a mindset within the developers that have to change in order for us to get where we're going. Because if we're always looking at what we could get away with, all it takes is one moment of weakness to go back to that, because the thing that we're trying to do will always be more expensive than the thing that we can get away with, the code minimum, right? The least, the most legal building that we can least build. So there was never a discussion about that. The goal from the beginning of each project was always to hit this target. So the conversation was less about superfluous exercise. I find myself examining things in my practice all the time where it's like, why am I doing this? All we're going to do is arrive at a more expensive solution they're going to do this, and then we're going to go back to what we were doing. And we study things to death, and it costs money and time to do that. When if the goal were to hit a target, we would just design accordingly. And so with both projects, there was never this thought of like, well, it's going to cost more to do this. It was just, this is the brief, and either you're the team to do it or we'll pick another team. And because that was the goal of the client, the budget reflected that, the dynamic reflected that, and the options that were designed reflected that. And so we don't have that number simply because it hit the target of the Class A pro forma of Waterloo, Ontario, which is a suburb about 1 hour outside of Toronto. So I wish I had that number, but I don't, because it doesn't exist. It just met the goal. And part of the reason why we met the goal is because we were working with this parametric analysis. So again, it was looking at every building system type. And also we would arrive at, if I go back real quick. So yeah, we looked at everything, and we could have never done this had we not had computer aided design or parametric aided design to help us. And what it did was it said, this option works for the goal. And there were, as we saw, there's 3 options that we identified that met the zero energy target. Then we priced those out. And that's when we went back and forth on the budget. And, again, we had to make some tough calls because we thought we could get all of this. And then we had to nix some things at the end because they just became unworkable or inflexible or undesirable. So, again, I think the issue is less about money and more about mindset. And when you're starting with X and you're looking at, well, what if we got X plus? X plus will always be more than X. But if the goal is X, then the conversation is just about how do we achieve X? And that is it's just a very different process.
You have satisfied everybody's curiosity, Blake. I think if you would put on your contact information again, please, so that people can take it down and get in touch with you directly. I think it is a wonderful presentation. You've really done yourself proud. I think it's important to understand that your role as sustainability director in this parametric design process. Can you talk about that a bit?
Good question. So, I'll introduce the, I'm gonna go back.
You've introduced your 3 partners.
Well, that's my point. That's my point exactly. And so, for Evolve One, I mean, what better strategy than to have on your team a German PhD who's a international passive house expert. So we did have that in our arsenal, and not everybody has access to that. And certainly not every project that we're working on has access to that, but it's a capability that we have for the special projects that come to us for that. And so, when we paired Porus and Dr. Frisk together on the team, they were able to deliver this in a way. And the issue is this, is that the parametric analysis is a thing, and it's not just something that we do. So I dug a little bit deeper into that question because I wanted to know, is this a proprietary skill, or is this just out there in the world and just awaiting people to use it? And what I learned is that we were using open source software to do this work. So every firm has access to this. And I think that we as architects have to send signals to the market by requesting this level of service from our partners. And if we're able to receive it, I think that it'll differentiate those partners, but it will set up the projects for greater success, not only in terms of achieving these rigorous goals, but just also in terms of getting the most energy efficient building for the lowest cost, which is really going to be that's going to be the sweet spot where everyone just says, yeah, this is amazing. Why do I want that? And so I think it's just a matter of, really asking for it, but also partnering with team members that are willing to go this direction. And a lot of times what happens is, certain partners in a team will be hired because they've delivered, X project many, many times and there's a successful track record. But I think in order to get beyond that, we need this level of service that is available to us as a profession. Whether we have the dream team or, or not, I think that at some point everyone has to catch up to where that is, and the tools are available to us now because this is open source. This isn't proprietary. It's just the willpower to use it.
Esther, why don't you announce that next meeting that we're holding so that everybody who has been here can realize that that's what we're going to be talking about next time. Blake, thank you ever so much. It was really fascinating. And I do hope we can invite you for some other enlightened real life experiences.
All right, sounds good. And thank you, everybody. Take care.
Thank you, Blake.
Thank you.
Thank you. Okay, so for October's presentation, we are going to have Hyper Sustainable School. The presentation will be October 19th. Will be presented by Patrick and his consultant, Mamchi. Patrick is from Perkins and Well, Patrick Cunningham. He has a very extensive portfolio in education buildings, and he's going to share with us regarding his experience and how he approached and developed the project. Please feel free to sign up for the next presentation in October. Thank you.
And with that, thank you all for joining us. See you in October.
Thank you. Thank you, Peter.